Welcome to the Mission Matters podcast, a podcast from Shield Capital where we explore the technical opportunities and challenges of developing and deploying commercial technology to national security customers. I'm Maggie Gray.
And I'm Matt Kaplan.
And we are your hosts from the investment team at Shield Capital. All views expressed by the hosts and guests on this podcast are solely their own and do not reflect the opinions of their employers or investment advice. References to any securities are for informational purposes only and do not constitute an investment recommendation or offer to provide investment advisory services. In this episode, we're joined by Mike Flanigan, the CEO of Seasats, a startup building the future of autonomous systems for the ocean. I'll say Seasats is definitely one of my favorite portfolio companies, in part because I think it's one of the easiest one of our portfolio companies to explain to people who work outside of this industry. They're building some super cool stuff. In short, Seasat builds solar-powered autonomous drone boats that sail themselves thousands of miles across the ocean.
Yes, and the Navy has decided it needs a lot of autonomous boats. One thing that struck me learning about this space is that the unmanned surface vessel industry isn't actually new. I mean, you can go all the way back to World War II, where several major powers used USVs for offensive operations, minesweeping, and even dummy practice targeting. And then 80 years later, you have this operation in the Black Sea in 2022, where the Ukrainians used remotely controlled drone boats to sink part of the Russian Black Sea fleet, and it's considered this watershed moment in maritime autonomy. And now Congress, the US Congress, is planning to allocate nearly $2 billion for USVs. So I think there's this important question of why now? What about future conflicts makes these platforms so important? And why cheap unmanned and autonomous vessels haven't been adopted at a large scale before? Thankfully, today we have Mike on the show to explain this unique moment in maritime history, both technically and geopolitically, and what it all means. Seasats is one of the leaders in maritime technology, so we're super lucky to have Mike here today. Mike, thanks for being here.
Absolutely. Thanks for having me on.
Let's start there. The USV industry isn't new, so why is there so much momentum for the industry today? And both technically and strategically, why was the Ukraine war the first time that cheap USVs were used for such an important strategic effect?
Good questions. Yeah, as you pointed out, Matt, the USV industry has actually been, I would say, like burgeoning or growing for a long time. It's kind of like been this building up momentum or maybe tension of like, okay, the commercial market value has always been there. It's very expensive to do anything on the ocean, which we can get into later. But the technology tipping point, I would say, has been held back. And then one of the interesting things about the, Ukraine-Russia war is that like full-scale conflict releases some of the rules of engagement. And that actually suddenly crossed us over the point where, okay, unmanned systems become incredibly effective and revolutionary, game-changing overnight. I think when the very first videos were hitting Twitter X of USVs sinking Russian ships, it was like, okay, the next day at conferences in DC and in San Diego and California and really around the world, people are talking about this. They're okay, we need to change what we're talking about because everything has changed for maritime. So I think that is really what led to the tipping point kind of unleashing.
Mike, maybe could you differentiate? I feel like we have both USVs, unmanned surface vessels, but then also ASVs, like autonomous surface vessels. So where actually is the tech today? What's actually being used on the battlefield and where are we heading?
Yeah, that's a good one too, Maggie. So USVs has been the traditional term, particularly for the Navy. They've gone with unmanned surface vehicles or vessels. It changes a little bit. We like to use ASVs to distinguish the autonomy. It's like, hey, you don't always need a human on the loop, as in, I mean, some things are really bad. Like a human in the loop would be someone like needing to take active controls just to continue the mission. Like imagine that's someone who's like holding down the go stick. That's a human in the loop. Human on the loop would be like someone's monitoring to make sure that it's doing the right thing. And that would be like a USV. An ASV would be like, okay, maybe the ASV is conducting its own mission, potentially without comms, and then it's pinging back information and asking for decision-making input. So like really an autonomous system. As far as we know, like particularly like some of the kinetic USVs that have been used would probably be properly termed USVs. they're using video feeds to conduct targeting where, an operator's watching that feed, directing the vessel, and conducting like final guidance maneuvers. And that's both from the Black Sea with Ukraine as well as in the Red Sea with the Houthis, as far as we can tell.
And like, why move towards ASVs rather than just stick with these remotely piloted USVs?
Yeah. So on that one, it's interesting. Like Ukraine, Russia, it's totally the modern lab in terms of warfare and like what's changing incredibly rapidly. One of the open pieces of contention is people saying like, "Hey, don't overlearn from Ukraine." I would say that that I'm more usually in the camp of like, hey, those people are usually in a traditional camp and have something to lose if things change and everyone wakes up to that. But one example where that's probably accurate is okay for like a real near peer competitor, like let's say um like a global threat like China. Really, you're probably going to be dealing with very sophisticated systems, like intensive jamming, intensive electronic warfare. And so, okay, a USV might not be appropriate because those links are very easy to pick up on in maritime and to cut and to sever and to disrupt. So you might need the autonomy. And I would say, in terms of getting to like also the second reason for needing autonomy is for persistence. If you think about, you have this scaling problem of like CSATs, we build these very long duration, very long range platforms. If we put out 1,000 USVs or ASVs, sorry, and they're out there for months at a time, it's very unscalable to then have a whole bunch of human operators watching. You really want someone doing that command level intelligence.
So, what is the state of tech? I guess first I'll ask of our adversaries. I know you mentioned China, you mentioned Russia. I know the Ukrainians are using some of these more remotely piloted systems. Like, where are our adversaries in both developing and then deploying maritime autonomy today?
Well, one thing's for sure, definitely China is, the manufacturing leader of the world, like it or not. And so, particularly if you look online, the number of USB systems that are getting proliferated by China is actually massive and incredibly cheap price points. They're not all, or the majority of them don't seem like very sophisticated or useful products. But at the same time, it's kind of like there is a quality to be faced of by quantity. If there's just thousands of really kind of crappy systems, like, well, you do need to contend with those. And I think that's one of the things that the US in particular has learned. Like, if we're talking about the state of technology and affairs, we'll go from, let's say, we just touched on China, which said, say, mass manufacturing, maybe the Red Sea, like Houthis. Okay, they're launching relatively cheap drones, like missiles, and then also USVs, and some really interesting USVs there attacks on, terror attacks on global shipping. But if you look at them, it's like these are very much like maritime IEDs, like improvised explosive devices. You've got like fishing boats loaded with explosives with like decoy, things in the front to look like a human driver to create confusion and uncertainty. Unfortunately, even such a crude system needs to be countered by usually more sophisticated systems. So the US ended up in this very difficult cost equation where it's like using expensive missiles to shoot down very cheap drones. So that's a problem. In Ukraine, I would say that they're at a little bit more of a sophisticated level with their maritime technology, where despite them being remote, they've shown definitely the world's leading implementation of USVs. I mean, they're launching 10 drones at a time to go do things. They're like swarming Russian ships, taking out propulsion first and then striking critical equipment second and doing follow on strikes, as well as now, you know, Ukraine has again kind of like opened up the history books and like made everyone look because they then mounted aerial vehicles and were launching long range USB missions with aerial strikes at the end into Crimea. And then taking that even further is kind of like, what is the logical counter to USVs? Typically aerial vehicles and really like helicopters are able to match speed and probably have the best like gunnery and perspective advantage to stop a USV. Well, then the Ukrainians added surface to air missiles and even I think maybe an FPV, but I might be wrong on that. But at least a surface to air missile and took down a helicopter and then took down a fighter jet. So now it's like, okay, even those counters don't make a lot of sense. So definitely the pace is changing extremely quickly. I would say, Ukraine is definitively the leader in this space, even if what they need to do due to their ongoing war is maybe not what the US needs to focus on.
So then where is the US Navy in this whole ecosystem in terms of actually adopting USVs and or ASVs at scale?
Yeah. Well, there's certainly a lot going on. The U.S. Navy is good that it has a lot of folks, a lot of like logistical power and a lot of budget to be spent on trying to solve problems. I would say it's been fractured and very spread out between many different groups, whether that's surface warfare centers, autonomy specific groups, innovation specific groups like DIU. Um, you name it. It's kind of like this was getting worked on in a ton of different areas. There have been recent big bets with like the replicator program by DIU and Hellscape. I would say that one of the common threads is everyone's aware that it needs to move faster. And one of the things that definitely like I see from the CSATs perspective, because we actually work with like a large number of the different Navy groups, both through their exercises, through combatant commands, and through field operations. Um, One of the things that I would say is like a common thing that a lot of the folks within these groups know, like the service members, is like, oh, we need to be testing in more realistic ways. The whole innovation cycle, like the DoD is very focused on like solicitations and like big bids. Unfortunately, that lends itself really well to like lobbying and marketing clout and like the fanciest proposal winning. And it does not lend itself well to effective, cost effective, and like mission success based products. So when we do see the DoD do kind of testing, I think sometimes the results are surprising. We can't talk about them all right here, but one or two of our customers, more in the special operations side of things, we've seen do like straight up competitions and end up with some like very interesting results that are not always the biggest names who have raised the most money.
Super interesting. I want to kind of pivot to the platforms that CSATs builds to your point, Mike, on some of the customers you work with, on the platforms that CSATs builds and what use cases you guys are focused on. So, yeah, we've all seen in the news recently that CSATs successfully sailed a Lightfish from California to Japan autonomously. And then separately, I saw you guys released a photo that was a high resolution image of a Chinese destroyer in the South China Sea. Yeah, those seem like a big deal to us who are outside the companies and the government organizations that are working on these problems. But can you contextualize that a bit for us? Like, are these things that every company is doing? And what do these announcements tell us about CSAT's capabilities and what you guys are designing your platforms for and why?
Yeah. Thanks, Matt. It definitely, I would say, is a big deal. It's pretty exciting. Our company was excited. Tons of our customers were excited, and tons of people just who follow the industry were excited. I think one of the reasons that this is a big deal is if we look historically at what and who, like what programs have been able to do cross ocean missions, they're all large. Like we're talking, 200, 300-foot ships. Typically, that's the amount of material and resources required to cross like multiple thousands of miles. Um, it's an interesting problem because, like, for the Navy in general, like these oceans are both like a great, historically a great protector of the United States, and any country that has big oceans is like, okay, someone has to cross that whole, like, in the investment world, we use the word moat to indicate like a very small ring of water around a castle or like a defensive piece of technology. It's like if you have an ocean protecting you, someone has to cross entire oceans to get there. And they need a way to get across. It's like you need, heavy equipment to be moved. So typically it's required massive ships and equipment. I think what was very important and kind of contextually relevant for the CSAT's cross ocean mission was, hey, we're showing that very small vessels can do this. And in today's day and age with satellite technology, RF sensing, etc., big things are very visible. Like the world's never been so transparent. And so ships, like it used to be that aircraft carriers could go hide in the ocean, like in the war in the Pacific, like Japan and the US were going around, didn't know where each other's ships were. We had to send out scouting planes to spot the fleet and then go engage. Now that's changed. Like people like satellite, the proliferation of low Earth orbit satellites, and like the intelligence agencies getting very good at their jobs. Everyone kind of knows where the big ships are. They even know where the bases are. Like this is becoming a massive problem for the DoD in general. So for small things to be able to do these missions is very important because we're showing, hey, small things that cannot be tracked are very hard to disrupt, are very inexpensive to build. So the cost equation's on our side. can be very, very relevant to today's missions because you can cross entire oceans. You can go put them within a couple feet of a key area, yeah, with great precision. So it's certainly kind of like, I would say, again, changing the understanding of what is possible.
So it seems like from what you're saying, the unique value proposition of CSATs is doing these long range, high endurance missions that are typically reserved for orders of magnitude more expensive and significantly more visible ships, really. And that's kind of the key advantage you guys have built. Is that fair to say? And are these the types of use cases you'll stick to in the future, or do you plan to expand the technology and product suite to other parts of the maritime domain as well?
Yeah, I would say maybe I'll answer the future expansion second, but I think the first part you hit is really like really good there. It's like, okay, things that were typically much larger and more expensive. So like you asked about the Chinese destroyer that we had kind of this like 20-minute encounter with on the Pacific Ocean journey. Well, typically a destroyer like that, like once like a carrier strike group goes out to sea, they're not going to encounter anything except for other large vessels, maybe occasionally the like long distance ocean going boat, commercial shipping traffic. But it's kind of an empty world except for these other large capital assets. Like no ships out to sea are frankly like as low cost as a Seasats Lightfish. So the fact that we're able to be out there and say like, hey, you have to contend now with the fact that like you don't just have like your watch be on high alert when you're within 100 miles of a coastline. It's like anywhere in the ocean we can proliferate USVs or ASVs and both deliver like high quality, high resolution, near real time intelligence, and potentially also layer in, offensive effects if necessary. So really, like it kind of changes the dynamic. Like just looking at that one specific one, like a Chinese Type 55 destroyer, that costs, I assumed it was probably a couple hundred million, costs nearly $1 billion to build. It's like $930 million. A Lightfish is like sells for $250,000. So it's actually less than that. But so really like just the asymmetry there is very remarkable.
Yeah, so on the, what you guys are sensing in the ocean side, one example, you're sensing and able to detect and characterize a Chinese destroyer. What are the other use cases for having this proliferated constellation of really cheap, um, low visibility ASVs that you guys make?
Yeah. One of the fun things is like we started the company very much in the commercial space. And so we've done work from subsea mapping, which is important for construction of like offshore oil and gas, offshore wind for monitoring pipelines. We've done work for the fishing industry, like shell fishing, monitoring water quality and alerting, unfortunately, like every year or so, like someone gets poisoned by shellfish that have toxic, like water in them. And so being able to like monitor those things in real time is very impactful to a lot of the like industries that drive the maritime economy. Um, there's a whole range of these things. It's a pretty exciting and interesting world. Like people, particularly the security aspect has gone up a lot in recent years. Like, it used to be that folks would build things in the ocean and then it's like, well, it's safe just because it's in the ocean. Like you lay down an internet cable or a pipeline or build a dam. And it's like, well, no one's going to mess with this. It's all the way out there. That has certainly changed. Like there's a lot of like gray zone conflict of people sabotaging equipment. And so now we're getting a lot of outreach from commercial companies asking us to do what is essentially like very routine security jobs. It's like, hey, we just want data analysis and very timely warnings so that we can protect what ends up being like many hundreds of dollars, many hundreds of millions of dollars worth of like critical nation state infrastructure. Um, on that side, it's very fun because like we're definitely in the lead in terms of commercially viable technology. Like to the state of U.S. Navy technology, there's a lot of stuff that's focused on like pointy, full-on warfare. However, like most of those products don't have the safety systems, the liabilities, or just the commercial viability to be at all relevant to the commercial industry. Many of them talk about dual use, but realistically, like, I mean, we don't see a single sale that they can point to in the commercial space. And that makes sense because the commercial world is much more sensitive to ROI and actual like stuff just making practical sense to a layperson rather than, in many ways the harder mission, but a very different mission of let's say delivering ordnance on a target.
Yeah, Mike, speaking of those commercial use cases, I mean, I think about like the autonomous vehicle industry in San Francisco. Matt and I both live in SF. I know we both take Waymos all over the place. And from a non-expert's perspective, like this seems like a harder problem getting cars driving on the streets of San Francisco where they might hit somebody, walking in the middle of the street or um where there's gonna be random U-Hauls just parked on the middle of the street or whatever. Like, the open ocean seems like it would be an easier, which I put in quotes, problem or technical problem. So I guess, like, why are we seeing the maritime space sort of lagging behind the ground vehicle space when it comes to deploying autonomy? Like, is this a regulatory thing? Is it actually a technical thing? Is it just a market-based, question? What's your perspective on that?
So I would say to answer it in two different lights. On like the hardware problems on a lot of the different things. I would put open ocean maritime robotics closer to like the space industry, like satellites and such, rather than the autonomous car industry. But I do think the autonomy is directly related to the autonomous car industry. So let's talk about that first. Um, I think that something that was interesting that we saw with like the autonomous car industry is everyone kind of thought that it was going to be pretty like that was like, oh, we can solve this right now in maybe 2018 timeframe, like kind of the breakout of some of the new machine learning models. And it's like, wow, computer vision's so much better, neural nets, like we're just going to smash this. And there's a huge surge of funding and companies, and then really none of them solved it. And the only ones we have left are Waymo and Tesla, who are like actively duking it out in relatively confined rollouts. Waymo we're seeing do is kind of like a very progressive, kind of like building chunk by chunk very reliably. And Tesla's kind of still this big unknown of like, are they suddenly going to unlock full vision based, incredibly affordable autonomous driving? We'll see. In the maritime space, we have the same problem. Like sorry, actually, just to characterize, like what held them up, like what killed all those companies. I would say this is a long tail problem. So the problem is that like 99% of the driving is easy and solvable, and they probably all did solve it quite well. But that 1% chance of like, okay, kid runs out from behind a car and a human driver is incredibly good at identifying in milliseconds and then jamming on the brakes. And we come to expect that out of autonomous systems. We don't want to let an autonomous system out on the road that is like just a terrible driver in these really important moments. Maritime has the same long tail problem. Like, okay, a kayaker comes up, a jet ski comes up, a tanker is crossing on a windy day through a tight canal, and there's a sailboat coming. And it's like the rules of the road say that one should give way to the other, but a captain or a mariner or pilot needs to make a tough judgment call to say, like, ooh, I I would rather let us bump than cause the situation like the Suez Canal or like the Evergreen that got stuck. You name these massive maritime disasters, like they're really tricky. They're basically this maritime still has this really high critical important moment, but now it's actually much harder because instead of having a massive bulk of training data to get through the bulk of this, there's very little. It's like it's very lulling. It's a false sense of security. Like you can go out and operate for months and say, "Oh, we have Colreg compliant software," and it's like, no, they probably don't. They just had very few interactions, and anytime someone gets nervous, they like switch on a Starlink and just watch the cameras and do a little nudging if they need. So I think that long tail problem is the tricky thing that's holding up maritime.
Mike, what's a Colreg?
Thanks. The collision regulations. These are a set of guidelines about how vessels on the ocean should interact with each other. And it's like the International Maritime Organization, or IMO, published them, jointly with a bunch of different nations. I don't know, maybe 50 years ago or something. And yeah, USVs have been struggling with them ever since.
Yeah, going a bit deeper on the tech stack, I want to better understand where CSATs comes into this. You talked about being the only company in the kind of military maritime space that also has commercializable product. You said you started commercial, have commercial customers, and then that would seemingly give you a lot of technical differentiation in kind of the intelligence and surveillance and reconnaissance, the ISR missions, right? Could you talk a little bit more about what differentiates CSATs technically from other companies in the maritime space or from legacy ship companies. And what are the hardest parts of that tech stack that you guys have built? What are the hardest challenges you've had to solve?
So I'll start with kind of the traditional companies and then move towards some of the newer companies. I would say the traditional differentiation is that maritime, like to build these ASVs, and I'm going to keep it focused in the offshore. So offshore and longer endurance. Like, okay, you need to be out for more than one day. So like greater than 24 hours and operating at least a mile offshore. When you do that, you go from hundreds of competitors down to like handfuls that say that they can do it and ones that have proven that they can do it. We're probably talking a single hand. Like the field thins dramatically. Why is that the case? It's because you need to solve a wide array of problems and you need to be competent or even expert at all of them. You can't just be good at one or the other. So there's a lot of like, boat building companies like we can build autonomous boats, but if they don't have modern software, they don't have great electrical engineers, they don't have kind of the full acumen of what these autonomous systems require, then like, yeah, they just don't succeed. It's a good looking boat, but it doesn't actually do what they need. There's other companies like in SF, I've seen some startups that pop up that are like, we know software. We're going to build like a sweet autonomous boat because boats are easy. And it demos really well. But you see like 80/20 aluminum. This is like a very common like prototyping aluminum, like stuff like rickety bolted together, ripping around for demos in the bay. And is like, that's essentially irrelevant to the real mission. It's like until those companies recognize that they need to hire really good mechanical engineers, really good naval architects often, and then even really good electronics engineers, like electrical engineers, because you can't find off the shelf, like if you just buy a Jetson, like an NVIDIA Jetson, cool. Okay. That typically sucks like 5 to 12 watts. Doesn't sound like a lot. Most of your PhDs in autonomy have not considered like a power draw being a problem. It's like, oh, if you're out for days and days and days, you need to manage your power budget. You need to switch things on and off. You need to handle different communications networks. Just the number of problems you need to solve is kind of massive. Like even just two I just mentioned there, like communications. If you just run a Starlink all the time, it's 60 watts. Okay, like now maybe you're having to run a gas generator. Well, guess what? If you run any type of internal combustion engine, like gas or diesel, you typically have a person service those every like couple hundred hours to change the oil, change the seals. Like even our cars do not run close to that long, even though automotive is one of the highest reliability industries in the world. Like they need a lot of servicing. So I think the problem here technically is that there's a lot of things to solve and it's very easy to start and it's really hard. Like it's just another one of these long tail problems. It's really hard to get to the last couple percent and those ones end up mattering in the ocean industry.
Yeah, I think that's a super interesting point about how to build from what you're saying. What I'm taking away is to build autonomy. It's not just a software problem, but especially in maritime, it's a hardware problem as well. But I feel like, we see companies in the space who are saying, hey, we know how to build boats. There's a lot of people out there who know how to build boats. We don't need to reinvent the wheel. We're just going to build the software that retrofits those boats, or maybe we make some slight modifications to handle the power or the comms or the other problems you just talked about. But we're not going to, have a proprietary design for our vessel because people know how to build boats. So could you talk more about why it's really important to be the ones building the boats yourself? Like, why not just retrofit boats with software kits and maybe a few other things that help you manage things like power and comms?
Yeah, that's a good question. And if we could buy boats off the shelf that did the missions that we needed, we absolutely would. Like we joke all the time that we're like, oh, we would love to outsource more. We wish we could outsource more. One of the things that Seasats started with was on these like man portable boats. So some of our our very first government customers were special operations. And they had these hard requirements of, hey, we need to be able to show up to a location and with just people get this thing into the water and start the mission and do that without like lining up a crane or a forklift. So that immediately puts this very hard requirement in terms of how much weight is acceptable. And so for us, we end up like very much in this composite, very compact space, trying to build these really long range, really capable stealth platforms. And they have that weight limit, weight and size. Now, because of that, we have to pack all this stuff in and do all this design work and really like we have to own the entire solution. It's not okay to like throw it over the wall and say, like, well, someone else will hopefully solve that and like vendor sends it back and it's a little bit too heavy. that has led us to a point where we're now winning sole source awards and where our customers tell us like, yeah, there's nothing else out there that is that size, that capable, that range, and has proven performance. Like it just doesn't exist. You can look at the trade space and there's dozens and dozens of companies and they make big things, they make fast things, they make short range things or small things, but nothing that hits both of those. Um, the cool thing is I didn't realize, and I don't think we realized just how helpful this would be for also commercial market growth, because it turns out that actually just shipping around the world is a huge pain. And if you can make something small and portable and very capable, then you can also ship it really affordably. So like we get a lot of contracts where we're like, hey, we need to do this thing in this other country, and we have like 6 weeks to do it. And there just are not many options for what you can actually commercially airship around the world. Like we're right at the limits. We already have to have people who are really experts in like shipping logistics, going through customs, doing all this stuff. So yeah, it turns out the size and weight, like I kind of like to think about this like cell phones or computers. It used to be that you had like giant computing rooms. And then it was like, hey, now it's only the size of a fridge. Then it's like, oh, now it's the size of, a refrigerator or like a microwave. And now it's like in our phone. And it's like, okay, if it's smaller, you can scale it better and faster. So really, everyone would do everything as small as possible if they could. Typically, you go bigger if you have to. So the smaller, the better. It's just that requires a lot more engineering.
Yeah, I imagine on the US government side, there would be a lot of kind of contested logistics interest in a platform that can not only be shipped overseas easily, but in some cases can ship itself overseas easily. Is that something that your customers have gotten excited about?
Yeah, I think that that's a cool one because in contested logistics, it's like, okay, how do we maintain a fighting force or stand in force when we've got conflict with an adversary and where like supply lines are not as easy? You can't just fly a big cargo plane in or extend like a big boat 'cause it's going to be a target. Well, the cool thing about the stuff that we're doing, if it's really a long range and small, is we can change this logistics balance, both in terms of maintenance. It's like, oh, hey, that might be difficult to maintain. We're like, well, what if you only have to maintain it twice a year? It's like, well, now, I mean, maintenance every 6 months, sure, just like stockpile a teeny pallet and you're good for multiple years. So you're like, you totally delete this problem by making the things be very, very uh, long endurance and like self reliant. And then the second one, like you mentioned, is they can just go super far. So it's like, great, you can basically get into contested areas and the smaller, the better. I think, yeah, like signature management is a huge thing that people are learning in terms of unmanned systems.
Yeah, I wanted to ask just another quick question about um, how you're designing for persistence. The the Trans-Pacific mission, what was the one where you went from California to Japan? What was the hardest thing to get right technically to make that mission successful? And from a design standpoint, what did you learn from it?
Hmm. Um, maybe it's just like all of the things. I mean, like there's the stuff that you don't want to solve, and those are probably the ones that are most important. It's like, oh, you could build the boat lighter, or you could build the boat faster, but you really need it to work day in, day out. And so just respecting those constraints and requirements, our vessel is a hybrid vessel. Not many people know that, but people either kind of like think like, oh, it's an electric motor, it's battery powered, and kind of forget that like, oh, the solar panels actually harvest an enormous amount of energy when you're very efficient with your budget. That's like for many months, like you need solar. Another thing is it's hybrid, like it uses a fuel cell. And that's really important because like it has the ability to work for weeks, even if it's very cloudy or near big storms, or like for other applications, we're carrying high power, like high draw payloads, like electronic warfare payloads. They require hundreds of watts. And it's like, okay, you can only kind of do that and then recharge quickly if you have a hybrid system. So that required a lot of engineering. That was very on. When we did our first prototypes, it was not hybrid, it's pure solar electric. We realized from doing missions that I was like, you know what? We need to bite off this hybrid challenge. And we invested in it. It took a ton of engineering. And some of the cross ocean missions actually did unveil some things about those hybrid systems where it's like, you're only going to learn those when you're having boats out in massive storms and huge waves. And it's like, okay, how do you choose the right level of simplicity versus complex? If you make the design decision to add some actuator to close some air vents, that adds configuration management, that adds extra parts to build, that actually adds extra failure modes, all these things. And so you need to like, carefully weigh the decisions to add those things. And those open ocean missions are really like where we prove that stuff out, where we say like, hey, here's where we're going to go validate our design. and share it with the world so that people know what the status of this technology is.
How do you guys go about actually building some of the machine learning models that you deploy on these systems? I know you mentioned, and we've heard from others, that there is a big shortage of maritime data to train something like a computer vision algorithm. Um, there's only so much real world testing you can do. So, yeah, like what does that pipeline look like from data preparation to training to testing, simulation, evaluation, all of that?
Well, I think we're fortunate that the machine learning world as a whole has moved forward massively. So we leverage open source models. So we like take kind of best in class, and then we have like our own data libraries that we've built up, and then we fine tune and train to a maritime perspective that's relevant to our boats, because it's all about matching data distributions. If you take like the best Tesla model and then ask it to do something random in your house that's never seen before, it's probably going to do bad because it just like hasn't actually seen that type of data before. So having like on target data is really important.
And is that just data that you guys have collected, or are you using, like, simulation or synthetic data?
Yeah, typically for us right now, like we've evaluated synthetic data, but right now we are, because we've got this advantage where we have like boats all over the world and they've been out there for years in some cases. We have a lot of data and we're getting more every day, like, and our amount of data is accelerating. So currently, the best data is real data. I anticipate eventually we're going to go to synthetic to replicate certain specific things that are really hard to see variety in. But right now, we're just sitting on a very good host of data. And I mean, we're even doing some data collection contracts for other folks in the industry because they're like, hey, we don't have a way of getting this affordably. And so, yeah, right now, I mean, put out a Lightfish.
And then are you doing all real world testing? Are you all doing testing and simulation?
Oh, we did a ton of simulation as well as like accelerated like hardware in the loop testing. I mean, that's very common in like automotive and aerospace. I will say with some yeah, probably like some pride and joy. Like back when I was writing software at Seasats, which is the very early days, one of the like things that I contributed was writing our simulation engine, like our first simulators, and that allows us to test a huge amount of our code um, without like the software ever knowing that it's not actually out in the real world. You can simulate sensors, you can simulate comms jamming, you can simulate a lot of things, and then we just go pair that with real world validation because certain things like comms degradation, there are tools to simulate, but a lot of times they're not quite accurate to the real world.
You mentioned that you now are actually selling some of these data sets to other customers who want to use it to train their maritime autonomy stacks. To me, that seems like something that can serve the whole industry and potentially be a large kind of part of what your company does itself, just because of the unique data quality and quantity of data that you're collecting out on the ocean. How do you see that in terms of being part of what your product offerings in the future? Is that a big part of it? And then secondly, are you planning to deploy missions for the express purpose of collecting data that you can sell? Or is this just downstream of having a bunch of Seasats Lightfish out there conducting missions that you're able to sell the data?
It started as the second, where it was like a downstream effect of already having the boats out there doing something. But it's definitely moving towards the first, which is like specific missions tailored towards getting specific data and then being able to sell that data stream. When we started the company and like our name, the abbreviation or the short form is Seasats, but the long form is Sea Satellites Inc. And so that's because we were in like a space-based accelerator, Techstars, and we had early investors and advisors who were all out of the space industry. And really, they saw what I fully believe in, which is that this is going to transition to the point where these USVs are very much treated like satellites, where it's like, hey, we have them, fleets of them out off coasts, off economic exclusion zones, able to provide continuous, affordable, high resolution data. And really, the people that need it, which is like Coast Guard, Border Patrol, DEA, like mapping services, fishing industries, they subscribe to that data. And they say, okay, I need to know when someone crosses into this area, but we become the contractor that keeps, the satellites working. It's like we maintain the boats, we improve the autonomy, we handle collision regulation, liability, all of these different things, and we just provide uptime. We've done that pretty successfully for the US Navy and for a couple commercial customers in a few different cases. And they've always been really happy, and we've always been really happy because it's a great business model.
Mike, have you all had to go through the process of actually integrating some of your systems with DoD systems or with a Navy system, some of their data feeds? I know we've heard We just did a podcast earlier with some technical leaders in the Navy, and I know they said integration is one of the number one challenges that they see startups and honestly primes alike manage. So we just would love to hear about how you all have gone through that integration process.
Yeah, I listened to that episode with Justin and Artem and totally agree. The integration problem is super key. Luckily for us, we knew this industry. Like we'd been in the space for, like 5, 10 years specifically before starting CSATs. And so integration was something we took seriously from the beginning. One way to solve that is making sure that you have very open APIs at the endpoints where they need to be met. So we do a lot of time writing software to integrate with like Minotaur, Lattice, L3 Harris systems, Copers, AFS, like you name all these different common operating and common intelligence or collaborative autonomy systems. And we've integrated with like, close to 10 at this point. And it's always pretty easy for us. Like we use standards that are well known, government developed, and are easy to work with. Um, I also really enjoyed out of that podcast, there's a question about just how hard it is like to get onto Navy ships or how hard it is to integrate with like operational units. And I think one of the things that was recommended on there, I forget whether it's Justin or Artem that recommended it, was like, look, initially go for standalone systems because it's easier to get the paperwork approved and then later like move to like fully mature, super tightly integrated. That's the route that we went and it's been successful. Like we've managed to get, CSATs onto gray hulled Navy ships in important parts of the world. And it's always done because basically people realize the critical need. They realize the capability that a CSATS vessel can offer. They look at its size and say, like, you know what? We can slap that in this area, have minimal approvals necessary, operate it slightly in parallel, and it offers the military a unique capability. And so that's how we've gone about integration. And then now that we're at the phase of kind of like larger sole source contracts, we are bridging some of those tight integration efforts where the government invests in saying, you know what, this is going to be something we're going to have for 5 to 10 years. And we need to like to wrap it in tighter.
And speaking of some of these government developed standards, I know one buzzword that I hear a lot is MOSA, modular open systems architecture. I'm curious, I've heard, I guess, maybe mixed things with positive and negative about it. I'm curious, like, is that real? Is that going into effect? Is that something you all are working with? Do you have any thoughts on it?
MOSA and UMA get tossed around a lot.
What's UMA?
UMA is like, I'm going to mess this up a little bit. Unmanned maritime something architecture, something like
Okay.
that. But MOSA, I would say, is the closer of the two to being like a good, realistic thing. And I would say MOSA in intent is excellent. Like we try to be accurate with our stuff. So we say that we're like a MOSA design system because it's like, they want to know that it's like modular open system architecture. And absolutely, CSATs, we design everything around that. Like we've carried probably like 40 different mission payloads from unique different companies doing unique effects. And it's like, it's probably higher than that now. I wouldn't be surprised if we're over 50. But every one of those requires like, if you haven't designed in a modular and open way, every one of those is like custom engineering projects. I mean, I've had folks from like Navy Information Warfare Center say like, oh yeah, typical sensor integration could be like $1 million in like a half a year to a year. We do it in like a day or two. And like sometimes we don't even charge because we're like, you know what? We just want our library to grow. If it's a mission value add sensor, we want to add it to our platform. We're just going to do this as fast as possible. So MOSA is important. UMA is important. I would say sometimes in the technical details, those things kind of miss the mark. Like they get a little overwritten, a little overprescribed, but the intent is correct.
Another technical question that I had was, how are you all seeing LLMs, transformers, play a role in maritime autonomy? Are you all actively experimenting with this, and where do you see the most promise for this technology?
We definitely do experiments because like there are certain parts of the autonomy perception stack that we have done LLM style or like these new large transformer models. And the initial results are super promising. They're like, because this is a long tail problem, they're like not quite there where we've like deployed them to vessels where it's like, okay, we're going to have to invest some time to try to get that right. I'm super excited on the LLM side in particular because we spend so much time, like we get a lot of compliments. We don't advertise a lot about our user interface, but we get a lot of compliments from customers of this like, oh, wow, this is super intuitive. This is one of the best things in the industry. I mean, I've heard this from competitors alike as well. They're like, oh man, how'd you guys get that so clean? I think the future of UX is going to be LLM. Like you're just going to talk to this tablet like the same way you'd talk to a person, be like, hey, it's getting dark. Should you change anything in your sensor behaviors? And rather than being like, let's try to make this intuitive, it's just going to be like prompt you with the correct settings. Or it's going to be like, hey, enter a stealthy observation mode. Hey, we're entering a contested area. Set yourself up properly. And I think that will be like totally enabled by LLMs. And I'm super excited to see that like uh, kind of workflow improve.
I want to ask about price and cost. And we talked earlier about the Ukrainian drone boats and sinking the Russian Black Sea fleet. Like the cost asymmetry there is enormous, and those boats cost 200K, something like that. And then, I was reading a Reuters article the other week that was talking about some of the challenges that the DoD's been facing with our own small USV industry, and it was saying that those platforms cost 1 million to 2 million, and it very starkly drew the contrast between those costs and the costs of the Ukrainian platforms. Why is there that cost asymmetry between what, say, Ukraine is spending versus what DoD is spending? Like, why can't we pay 1/10 the cost that we're paying now and buy 10 times the vessels? And then also just curious how you think about the right way to price these platforms more broadly.
Yeah. So, I think that Ukraine is in a unique scenario because they're in an active war. Every dollar, every round, every life matters. So they need to make really conscious decisions. Like they don't have the luxury of time or space to potentially get something overpriced or to invest in something that doesn't have an effect. Like, the like bird in hand versus two birds in the future, or whatever thing. Like they're taking birds in hands all day. And so uh, it's interesting, like when they put out their like open source crowd-funded thing for I think the Magura platform, which was the very effective USV for driving back the Russian fleet, open source available information. They're releasing those at $250,000, I believe, US. And so it's like, okay, that's a pretty good analog. Like they wouldn't post that number if they thought that was wildly overpriced because they're opening up to the world, being like, hey, help us fund these things. Like it's not like they're soaking up huge profit margins there. They're trying to drive ahead in a war. So I think that's a good reason just to recognize like, hey, maritime's hard. You need a lot of these systems to work. You need waterproofing on almost everything, which drives down the volume, increases human touch time. So like maritime's expensive. Ukraine is probably a bottom price. Like that's probably like the simplest systems that you can make, even though like to their credit, they're the most sophisticated in the world in terms of effectiveness. Uh, in terms of in the US, I think that article quotes like a Saronic platform at maybe $2 million. I'm just quoting what they put out there. Uh, I think there's some challenges here where it's like, okay, like the US DoD is very used to asking for very high end capability. So it's going to be more expensive. And they're preparing for a very high end conflict. So it's like, okay, you need really sophisticated systems. They're definitely going to be more expensive than like the cheapest possible systems on the market, which let's just call like Ukraine or China. So it's like, okay, some price between 250,000 and we don't know what the upper end is. Maybe it's 2 million. How we think about pricing is from like a commercial value stance. And it's like, okay, could we realistically just replace this boat with people and contract it and go do the mission? And it's like, if you're in the millions of dollars range, it gets hard to justify. Like you can do that really effectively with just like commercial solutions. Um, and frankly, like, yeah, I think that also becomes a crutch. Like if you think about the liability, like I don't know who the CFO is at Saronic, but if you tell the CFO at Seasats or Saronic, like, hey, we're gonna be driving around like a $2 million asset offshore unattended. It's just gonna be floating out there for days. They're gonna be like, ooh, what's like our financial risk liability position on this? And suddenly it's like, well, how about we have like, a couple $100 a day chase boat out there with a crew to attend it. And now once you got this chase boat out there, then it's like, well, we can also have a backup comm system. We can do all these things. You end up in a totally false, fake, basically testing environment because you always have someone there to baby the system and to bring it home. Like you don't need to get good at like navigating remotely through channels and difficult things because you basically always have a human to kind of watch it. So I think that's a problem with these really expensive systems is they get expensive and then they get babied during testing. So we were really aggressive about keeping our price low. And right from the start, we were doing fully unsupported test missions. And we could only do that. Like when we were bootstrapping and like we're starting this off of like extremely small amounts of angel funding, like we couldn't put out a multi-$100,000 system because we literally didn't have like hundreds of thousands of dollars. We had to like be confident in our equipment at like very low price points.
Do you think that the fact that the US is looking for boats that have more autonomy capability on the software side is making their platforms more expensive? Or are there parts of the technology stack that are more sophisticated than what the Ukrainians are using that make it necessarily more expensive?
More sophisticated, probably yes. Whether that's more mission effective is the open question. It's like, okay, who can complete missions better, which is like what you need at the end of the day. Um, if you just want like a nicer car, then you can always go up. You can be like, all right, I want like a Porsche or a Ferrari or a McLaren. Like you can spend more money if you've got more money to spend and if you want nicer things to buy. I don't think inherently the software needs to be that expensive. Yeah, it's not a very hard computer vision problem. So I don't think it needs to be as expensive as it is. I think the prices will come down, and that will put pressure on companies to find viable price points and viable dual use solutions, or to go out of business or have down rounds. We'll see what happens.
Last question on the lessons from Ukraine. You talked earlier about, how you balance learning and not overlearning. Um, are there lessons from Ukraine in the maritime space that you think specifically don't apply to a future US conflict, or how the DoD thinks about its posture in maritime autonomy?
Yes, absolutely. I think that a lot of folks saw the Ukraine very successful uh, defense and offense with their USVs and said like, "Pooh, we need exactly that." I would say it's very worth remembering that like Ukraine was a defensive nation fighting a war against a much larger aggressor and in an all-out war scenario. Like I like to consider this back to like wars in the Middle East, like Iraq and Afghanistan, to like roadside IEDs or improvised explosive devices. Like the IED problem was a massive problem to US forces, but there were not like a dozen IED startups that were like, hey, we should be building like IEDs for the US. It's like, no, like cheap defensive weapons are not what the US invests in. We typically are investing in like precision strike missiles, aerial systems, etc., that also have like really advanced safety systems, like for morality purposes, like last minute aborts and things, which drives up the cost. So I'd say now the US is in the unfortunate situation of potentially facing like near peer conflict, where it's like, okay, we can't have as exquisite systems. Like economics are a real factor. But at the same time, I don't think like, waterborne IEDs, like super cheap kinetic solutions, are really like the right place for the US to invest in. I think we need to look at like those lessons and build new ones, or build like more appropriate things to build into like US doctrine.
Transitioning now to some rapid fire questions as we get close to closing out here. What's been the biggest surprise building CSATs?
Maybe just the number of places and like the number of needs and things we'd get involved in. I think like Elad Gil's handbook, startup handbook or whatever that book is, it talks about like not realizing just how big the world is, and that is totally true. There are so many people who reach out to us on literal cold inbound sales, and I'm like, I did not know they would need autonomous boats.
What's like the most surprising one of those, if you can share?
uh Jellyfish detector. We like didn't know if this was a joke or not, but it turns out that like nuclear power plants are like typically by water sources, and they have like big water grates. And then if you get like a big plume of jellyfish that like float along like on a growth, then they'll like clog the grate, and like suddenly you'll have like everyone panicking about a nuclear meltdown because like they can't cool the plant fast enough. And so like, yeah, these folks building power plants were like very seriously contacting us in the early days and like doing presentations around using like fleets of CSATs to provide like early warning to like underwater jellyfish swarms. And we're like, but yeah, we thought it was a joke at first. That's definitely the weirdest.
What's your hottest take about the current state of defense tech or maritime autonomy?
Ooh, there's so many hot takes. Okay, here's one. I think that there should be way more testing. Like everyone is excited. I think like what has really happened, like why are defense companies like clustering and racing to Ukraine besides like protecting democracy and helping like a nation protect their like, sovereign borders and stuff? It's because they've become the de facto testing lab for the world in terms of defense systems. What is like the big shame to me is that the US has so many regulations that like we have failed to create effective test environments in the US. And I've talked to folks in the government about this and folks who are trying to reshape things. And my end conclusion is often like, gosh, we should probably like raise some money and just like purchase some private land or like purchase some like areas and just run a commercial testing facility. Cause it's crazy that we're so bad at this. I mean, I love looking at zipline drones. They like couldn't get FAA permission to do like early UAV stuff in the States. And so they just went, overseas to do testing, delivering like important medical supplies where they could do it.
How far out do you think we are from being able to take like an autonomous cruise ship?
Oh, I love this question. I can't say never because that surely is wrong, but I'm going to go 50 plus years.
Oh,
And
man.
I know that might sound like a pessimist. It's not for a technology reason. It's just like airplanes, commercial airliners have been able to automate the entire flight, the takeoff and the landing for a long time. But like we need pilots for like liability, for responsibility, for like there's so many reasons that humans are so good and versatile. Like when you're talking about like big cruise ships, like it kind of just doesn't make sense. Like someone was telling me they're going to get rid of the final crew on these super tankers. And it's like, really? There's only like 15 people on there and they're
Okay,
transporting.
what about like a whaling
Yeah.
boat, like whale watching? So there's like 10 of us on here or
Okay.
something.
Okay. We have toyed about offering around Mission Bay, like beer cruises where our autonomous boat just like tows people around with like tubes and coolers full of beer because we've done that for ourselves. We're like, this was kind of a fun gimmick. Like we should like have people get toured around for romantic cruises with no driver. That might be sooner. We could do that kind of whenever you want. If you want to Venmo us, we could probably do it once illegally.
Hey, specifically in the USV space, what's the most commonly misunderstood you kind of viewpoint about the industry?
I think the one, this is just like over and over, I like beat this point, but I would say just the demos are done on days when everyone wants to go to the water. It's like, it's sunny, it's nice. Like if it rains, it pours and it's bad weather and then like everyone doesn't do it. And it's like, oh, that doesn't make sense. And so often the like tests are scripted. It's like, okay, and now the bad guy's going to come and we're all going to like point the cameras, point the weapons and like report our duties. It's just like totally fake. And so like the combatant commands are actually really like the point of the spear in my opinion on this because like they're out there doing missions in the world oftentimes that like are not scripted. It's like, okay, trying to like stop smugglers, trying to stop, like conflicts and like being in kind of like more contested zones. Even like Fourth Fleet, I was reading an article where it was like, hey, we should be using this as a more aggressive testing environment because we're trying to stop smugglers. And it's like, and it kind of is separated from adversaries. That makes total sense to me. Anything that can make it more real is critical.
What advice do you have for other founders looking at starting a company in the national security space?
Find amazing investors and teammates and advisors who get how long it's going to take and how hard it is because like just like maritime defense is a problem that you can't just be good at one thing. You need to be kind of like amazing at one thing, which is what gets you your differentiation and that like classic startup 10x improvement to get people to try it. But then you really can't suck at anything else. It's like if you're bad at contracting, if you're bad at legal, or if you're bad at some core competency in your technology stack, then like it's just kind of doomed for failure. Like you'll never get all the way there because you need to be good enough at everything. And I think the only way to do that is to have a good team. And like that counts all the way to like the investor network, which, Shield Capital is a phenomenal investor. Nice plug for any startups looking for capital.
Well, on that note, Mike, thank you so much for coming on the podcast. I definitely learned a lot about the world of maritime autonomy and really appreciate your time.
Totally. Thanks for having me on, Maggie and Matt. This is a lot of fun. Glad to be on here and glad to get to share a little bit about what's happening in maritime.
Hey, everyone. Thanks for listening to the Mission Matters podcast from Shield Capital. Tune in again next month for another conversation with founders building for a mission that matters. And if you yourself are looking to build in the national security space, please reach out to us.